In this video, we're going to talk about salt hydrolysis, which is a type of reaction between an acid and a base. We're also going to go over the salts produced from this reaction, whether they are acidic, basic, or neutral, which will let us predict the results of titration experiments to see if at equivalence point the resulting solution will be acidic, basic, or neutral. Right, so in the previous video, what we talked about was a reaction type called proton transfer. In proton transfer, you have an acid HA, you react it with a base, and what happens? The acid donates the proton to the base, and you wind up with A- and HB+. Right, so this right here is proton transfer. Neutralization works a little bit differently in the fact that for a neutralization reaction, the base is always a hydroxide. Now, if you react a hydroxide base with an acid, you wind up with a salt. Salts are just ionic compounds and water. Right, so if we react hydrochloric acid with sodium hydroxide, it's a type that, remember from sophomore year, is double replacement. You form sodium chloride, which is your salt, and water. Now, to figure out whether the salt's acidic, basic, or neutral, we have to go back for a salt and look at what the parent acid and base are. Right, so for sodium chloride, the way that you make the parent acid is you take the anion and you put enough hydrogens on it to balance out the charge. Right, that gives you the acid. For the base, you take the cation, the metal, and put enough hydroxides on it to cancel out the positive charge. Right, so if I just give you the formula of a salt, you can figure it out this way. So if I said, for example, a salt was, let's say, calcium acetate, right, so C2 or CaC2H3O2, then I can figure out that the acid is the acetate ion plus hydrogen, so HC2H3O2, and the base is calcium with enough hydroxides to balance its positive 2 charge, or CaOH2. Right, so this is how I can get the parent acid and parent base from any ionic compound that we may be using. Right, so what we want to be able to do for titration is when we're doing a titration, we want to be able to predict where the endpoint is, or roughly where the endpoint is, so that we can choose the right indicator to use, because different indicators change color at different pHs. And the way that we do this is actually quite straightforward. Right, if you have a strong acid and a strong base, they both 100% dissociate, which means that the reaction goes all the way to completion. So the salt that you produce will be neutral. Another way to look at this is, if we remember from our previous video when we talked about the strength of conjugate substances, a strong acid has a negligibly strong base. Right, so the conjugate base of a strong acid is negligibly basic, so virtually not essentially neutral. Right, this right here is the same. A strong base is a negligibly strong acid for its conjugate pair. Negligibly strong base, negligibly strong acid, they're neutral by pretty much definition. Right, now if we switch over to a strong acid and a weak base, strong acid is stronger than the base is weak, so the salt will be acidic. And again, if we look at the ions, the conjugate base here is negligible. For a weak base, the conjugate acid is a weak acid, right, so weakly acidic. Well, weakly acidic and negligibly basic will make a salt that is slightly acidic. Same thing if we reverse it. Weak acids will form weak base ions, whereas strong bases form negligibly acidic ions. right? So the base conjugate here is stronger than the acid conjugate, therefore the salt will be basic. Or the other way of saying it is the base is stronger than the acid, therefore the salt is basic. So either way you want to do it, whether you do it with ion strength or you do it with strength of the parent acid and parent base, it will get you to the same place. Now, we have one more combination, which is what do we do if it's weak-weak? Right? Because weak-weak presents us a problem in that the only definition for weak is that it dissociates somewhere between slightly above 0 and slightly less than 100%. So that's a very wide range of acidic and basic strength. Right? So probably the easiest way to do it if you're given K values, so Ka and Kb, is to compare them. Whichever one is larger wins. But in reality, we never work with weak-weak combinations in the lab because we can't accurately predict without having access to these constants where equivalence is going to happen, what type of salt you're going to work with. So it's not really that useful. If we ever want to titrate a weak substance, we will always use a strong substance to pair it with so that we can at least know on which side of 7 the answer is going to be. Right, so this is pH of salt hydrolysis. Easy way to do it is find the parent acid and base. Whichever one is stronger wins. Aside from that, you can use the strength of the individual ions